Welcome to a short video on titration. In KCSE 2019, the examiner did not test this area, and that was quite abnormal. Normally, examiners will tell you that it is always mandatory for this question to come. And because it was absent in 2019, there is a probability that it will be tested this year. But if it is not tested, don't crucify the examiner. It is just a probability. There are three types of titrations. The first one is called direct. It is just a direct involving the basic neutralization reactions. The other type is back titration that involves two tables, and the last one is redox titration. Direct titration and redox titration have one thing in common, that they are both the same thing in terms of calculations. The difference in redox titration is that it looks specifically at oxidizing and reducing agent kinds of reagents. And the back titration is simply a type of titration that involves one reactant being in excess. So we look at direct titration and conclude shortly with redox titration. We shall use a sample question. And in this sample question, you have been provided with 0.1 molar sodium hydroxide solution A and HCl, hydrochloric acid. Obviously, the concentration of hydrochloric acid has not been given. It therefore means that the question will require you to find the concentration of solution B. This concentration can either be in grams per liter or moles per liter. This solution, whose concentration is known, the sodium hydroxide, is called standard solution. The concentration is known, and therefore you can also call it primary standard solution. And once you get the concentration of hydrochloric acid, you are going to call it secondary standard solution. So here we normally begin. And to begin an effective titration question, you must always break down the information given into simple bits that you can be able to understand. So we begin with this 0.1 molar. What is 0.1 molar? 0.1 molar just means 0.1 moles dissolved in 1 liter, 1000 centimeters cubic. So these 0.1 moles were not used, all of them, in this titration. So in the procedure, fill the burette with solution B. Solution B is hydrochloric acid. Pipette 25 centimeters of solution A into a conical flask. So before we go down to titrate, we already know that 1 molar means 0.1 moles in 1 liter, or 1 dm cubed, or 1000 centimeters cubic. That means in a pipette you are asked to only take 25 centimeters cubic. So you ask yourself, if 0.1 moles were in 1 liter, how many moles will be there in 25 centimeters cubic? Because you are only taking a proportion of the 1 liter that you are provided with. So you'll be able to get the number of moles in 25 centimeters cubic of solution A that reacted in the neutralization reaction between sodium hydroxide solution A and your hydrochloric acid. You are titrating solution A with B using phenolphthalein indicator. Then you've been asked to complete the table. So our table looks like this, and these are my values. But before we get to our values, in every titration reaction, you should always write a balanced chemical equation. A balanced chemical equation will give you the reacting ratios, or what we call stoichiometric reacting ratios. Hydrochloric acid reacts with sodium hydroxide in the mole ratio 1:1. So this mole ratio 1:1, what does it mean? That when 1 mole of HCl reacts, 1 mole of sodium hydroxide will react. In our provisions, we had been given 0.1 molar of sodium hydroxide, which we said it is 0.1 moles present in 1000 centimeters cubic. But in our titration, we only used 25. So the moles in 25 centimeters cubic that you pipetted are the same number of moles that reacted for HCl, because our mole ratio is 1:1. And we can get the mole by either this method of equating 0.1 molar is equals to 1000 centimeters cubic, what about 25, or you can multiply your concentration with the volume, and this volume you have to convert it to 1 liter. So after you've titrated, you're going to get this table. Our table gives us the volume of B used as 20 centimeters cubic for the first trial, second 20, and the third 20. Remember that this table normally have 5 marks. Mark number 1 is given for completing the table, and it will always be given the abbreviation CT. Complete table earns you a mark. The other important mark is decimal. The decimal point, if you choose to use 1 decimal point, ensure you use it as 1 or through. If you choose 2 decimal points, let them be 2, and they can either be 0, they can either be 0.00 or 0.05. You can never have 0.04 or 0.07. It is either 0.00 or 0.05. The other mark is normally for accuracy, and this accuracy is normally awarded marks in 2 areas. The volume of B used at this particular point, and also it will be awarded when you get the average titer. So this mark is normally compared with the school value, and your values must always be within a range of 0.1 for you to average, and the average is given by titer 1 plus titer 2 plus titer 3. These titers can only be averaged if they are within the range of 0.1. For example, if one of the titration was 20.09, you cannot use it, so you'll only average 2 of them. So always ensure that you fill the table to completion. It gives you 3 marks which are free without doing any calculation. And here we go to our questions. Calculate the average titer. We have already seen how to do it. All of them are within the range 20 is to 20 is to 20. And then question number 2, solution A. How many moles of solution A were present in 25 of centimeters cubic? Remember what we said in our previous slide. We said that 0.1 moles present in 1000. What about 25? So from our table, we have been asked again the same question, and therefore we can see how it's being calculated. And the working here goes like moles is equals to molarity times moles in liter. You get 2.5 times 10 power negative 3 moles. Remember that our mole ratio is 1:1. So having calculated that, the next obvious question is calculate the moles of B. Remember that our ratio is 1:1. Therefore, from the chemical equation, and you should always write it, you are going to get the same number of moles for HCl as those of sodium hydroxide. Then molarity. Molarity is given by moles divided by volume in liter. Our moles were 20.5 times 10 power negative 3. For our B, the volume that reacted was 20 centimeters cubic. So you are going to convert 20 centimeters cubic into 1 liter, and then you multiply by the moles. Moles you complement with that particular moles, you multiply by volumes in liter. So having calculated and obtained 0.1, that is the secondary standard solution, and your calculations are complete. The next kind of titration is called redox titration. Why do we call it redox titration? It is because it involves the use of oxidizing agents. In this case, you have been provided with potassium manganate 7, 0.1 molar. 0.1 molar simply means 0.1 moles that are present in 1000 centimeters cubic. You have also been given an iron 2 salt, solution B, and this particular salt, you've been given the mass as 8.5 grams of ammonium iron 2 sulfate crystals. So here you've been asked standardized acidified potassium manganate 7 and determine the value of X. Now, these particular compounds are just scaring you for nothing. The most important part in this case are two simple things: understanding the chemical equation. Ignore the entire salt. Obtain your iron 2. Obtain your iron 2 which you are using in this reaction, and also get your potassium manganate 7. So the most important part of that complicated salt is iron 2, and the other important part is potassium manganate 7, especially this part. So here, the only thing you should be able to understand is the color of this salt and the color of this salt. And then also understand that ion 2 will be converted to ion 3. Potassium manganate 7 will be reduced from MnO4, it will be reduced to Mn2 positive. It will be reduced, this will be reduced, this one will be oxidized. And why are we saying that? We are saying that because oxidation is electron loss. Iron has lost one electron and its oxidation state has changed from 2 positive to 3 positive. And that electron which has been lost has been gained by potassium manganate 7. This means ion 2, which is normally green, will change to brown. Ion 3 salt is brown. Potassium manganate 7 is normally purple, but it will change to colorless because it has been reduced. Remember, reduction is electron loss. And here we are going to have our equation, and this equation is ion 2, 5 moles from balancing, 5 moles is to 1 mole of potassium manganate. And we shall see how we calculate this in our next video.